All right, let's get started with week 5 data visualization, something near and dear to my heart. And in the next lecture, we'll go over the objectives from the syllabus and the course content folder. We'll define data visualization, show the just basic chart types, and then I wanted to talk a little bit about specialized visualizations. We've got to go into Gestalt principles, which is the underlying psychology of perception that feeds a lot of best practices when it comes to data visualization. And I wanted to show you Microsoft Power BI. Some of you are developers, software engineers that might not have ever brought up this user interface. So just wanted to show you real quickly what the workflow looks like, what the tool looks like. And it's a free download. And there's any number of tutorials to get started out there on the Microsoft website and YouTube. And then I've got like LinkedIn Learning and Pluralsight subscriptions, which are inexpensive. So yeah, it's a next level tool. If you're publishing results, you need to do it in Power BI, not Excel, if you can. So our weekly objectives, there are only 2. Describe how data visualization helps in predictive modeling. And we can talk about that somewhat when we get to that chart. And explain data visualization. Well, data visualization is something that you should be thinking about like a researcher. For the 2.3 people that are watching this in a timely manner, you'll remember that I'm constantly reiterating that a PhD course isn't to teach you Power BI or Python or some tool. It's to get you familiar enough with the topic that you can then conduct research on it. So when you think about data visualization, start to think about how you would research the effectiveness or ineffectiveness of a set of tools or a set of techniques or an environment where you're putting data in front of people in the form of some sort of picture as opposed to just the raw, CSV level numbers. So columns of numbers, and the numbers are in the thousands, as we all know, won't tell you much, right? Think of every spreadsheet you've ever seen, the raw data CSV format. And yeah, looking at the numbers doesn't tell you much. But a quick graph or two can start to really bring things into perspective. So it turns numbers into representations the human brain can pick up on more quickly. And in an old syllabus, it said, we had an article that said data visualization techniques are authenticated scientifically as 1,000 times reliable rather than textual representation, which was a Google Translate, I believe, version of a picture is worth 1,000 words. I don't know if y'all have heard that idiom or not. A picture is worth 1,000 words. I think it came from journalism back in the day when photographs were new. So there are many, many examples of visualizations. A map is a visualization of latitude and longitude. It's not a photograph, right? A map, they can come close, or it can be a satellite photo or an aerial photo. But a map is a graphical representation of data, of latitude and longitude, of the size of a city. The bigger the dot, the bigger the city. The bigger the line, the bigger the road, and a bunch of other shading to see if it's a public um, public park, public area of the map, or if it's like a pink restricted military area. They use all kinds of different symbology on a map to represent uh, data, to represent what something is. Different actual types of symbols, like on Google Maps, they use a little cocktail glass if it's a bar. They use like a car if it's a gas station, or a gas pump if it's a gas station. So there's iconography, symbology on the map. Yeah, and then you've got simple charts that we probably all learned in junior high, all the way up to actually walking around and interacting with your data uh, in virtual reality. Um, Kind of like Tom Cruise in Minority Report, flicking data all around the place with his VR gloves on. So there's any number of techniques from ancient to cutting edge that are used to make sense in the human mind of all of that data. And there's a couple of people that, if you're into data visualization at all, you should probably have heard of. One is a German psychologist 100 years ago, Gestalt, um, wrote out some laws of human perception. We'll go over those. But Edward Tufte is more recent, still alive, writes a series of books on data storytelling and data visualization, and how to take things beyond the basics. He's got a video lesson on sale online for a couple $100, but you get all 5 of his books in addition to access to the video. And then for data visualization, there are many tools available. You can, of course, Excel has charts. You can do virtually any chart you've ever heard of, and a lot you haven't heard of. I hadn't anyway. In Python or R. But as far as business intelligence dashboard visualization of business information, your 2 leading solutions are Microsoft Power BI and Tableau, and I think Tableau still has the lead. There are others. I work with a company that uses a product called Domo. They're listed in your classroom. I'm seeing interactivity, and where you get to click on things and it modifies the data display for you. That works in Power BI, Tableau, somewhat in Excel, and animation, particularly, I'm seeing in JavaScript library based visualizations that are viewed with a browser, like data driven documents, D3. If you're a web programmer in any of this sphere, shoot me an email if you work with data driven documents. I'd love to know more about how that works. Okay, so that's the basics of data visualization. Now, basic chart types. You've got a column chart, can be a single data series or 2 data series. For here, we have annual population data. And it shows in blue dolphins versus whales. So this is your quintessential column chart, actually a clustered column, because there's more than one variable. So you can have as many data series here, like we have dolphins and whales. So it's bivariate analysis. You can have as many as you need. Just got to make sure that it's a meaningful chart. A stacked column chart will take, like for example, on 2017, it will take the 80 whales and stack that on top of the 150 dolphins to get a total for the time period. and the entire chart will do that. So it's a way to show um, a data series contribution to the whole number, kind of like a pie chart. Um, Only it's in the form of a stacked bar. And again, that works if you've got, just like a pie chart, you can't have too many colors, can't have too many slices, can't have too many stacked bars, or it starts to get difficult to read. But as we can see here, dolphin population is crashing, or at least the observed dolphin population is crashing. So you could do a line chart with this just as well. There's always frequently options when it comes to what you're looking for. Um, yeah, there you go. So column chart, line chart just looks at generally at data over a time axis. Your x-axis is generally a some level of time. It could just be relevant event, you know, but generally you put years or fiscal quarters or something there. And then your data series, your actual lines, are the things that are changing over time. So one of the one of our objectives, right, was uh, how data visualization helps in predictive modeling. So we go back to the line chart, and if you look at the light blue line for bears, and we've got data from the last 6 years, including up to and including this year, what would you predict? And right now, the population of bears is what, 181? What would you predict the population would be in 2023? I would predict it to be 205, 210 maybe. And that's um, without even running linear regression and getting a more exact number on it. But yeah, data visualization can show you trends that are going up. And then dolphins started out at 150 and then crash, 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 crash. I would expect the population in 2023 to be near zero without, I think you've got sufficient data that that would be your, I don't know, relevantly accurate hypothesis anyway. The gray line's a little harder to see. It fluctuates up, down, up, down. In fact, whales have never had a year that repeated the trend from the previous year. In 2017 to 18, it went down, then it went up, then it went down, then it went up, then it went down. And it could be some sort of a feast and famine cycle. So maybe next time it'll go up a little bit. So I would expect it to be uh, up around 90 or 100 if it follows kind of that cycle. And of course, there are tools in different pieces of software to estimate cyclicality like that. The much maligned pie chart. Um, it's good for showing portions of a whole. The pie represents the total of all wildlife in this example, and each wedge gives you the proportion of bears, dolphins, and whales that contribute to that whole. These get overused poorly because they're too many wedges, and or the wedges are too difficult to tell. Um, they're too similar looking, so you can't tell a 10% wedge from a 12% wedge. So it starts to take away the impact of it. But if you've got something like this where it's easy to see that, dolphins are basically twice of bears and, or I'm sorry, twice of whales, and bears make a tiny contribution to the population. One thing to show back on the line chart, you'll occasionally get series that are a different scale. These are all in the same scale: bears, dolphins, and whales. Sometimes your tool will put an extra scale on the right, an extra y scale on the right, if you're just doing two variables. But it can be confusing because depending on how different those scales are, what it can diminish a a rather dramatic change. Got to watch out for scale in a visualization. A bar is just a column on its side. Area chart starts to show you contribution to something like over time, cumulatively, like the sum of the different areas, product one and product two. So this is like a stacked bar chart over time, um, that shows you the cumulative contribution of product one and product two to sales. It can be confusing because um, you got to start doing some stuff like when um, um, product two is dark, right? The only time you see product two is in this tiny triangle in the upper right hand corner. It is shaded and behind product two in most of this chart. So data hides behind other data in an area chart. So it really only makes sense if the data doesn't overlap like this, and you can put the taller thing in the back. Anyway, they're available on every tool. A histogram looks a lot like a column chart, but it's not. It's a way to show the distribution of a continuous variable by putting the number of occurrences within that continuous variable um, into bars, bins, and then displaying them on the screen. So this is um, a distribution of heights, and it doesn't have to be continuous data. It can be, it just can't be categorical or whatever, something like that wouldn't make sense. So this is male employee height, measured every person to the nearest inch, and then reported that data. So we've got what? Let's count all the occurrences here. 3, 9, 18, 28, 35, 39, 41. So we got about 42 observations here. And we want to see how they're distributed. Remember back to the normal curve, the bell curve. When you're analyzing data, the data that is highly skewed to one side or the other might cause you to want to use median instead of mean as a measure of central tendency. But this data looks pretty normal, I would say, with 510 being your pretty much your mean and your median and your mode. So that's a pretty fair example. And you can modify the size of the bins. These are to the nearest inch. Maybe we took measurements to the 1/8 of an inch, but this histogram bins them all to the nearest inch. And another way to look at the distribution and symmetry of a single variable is with a box and whisker diagram. This shows the spread of data just like a histogram, where the median is in the middle, the first and third quartile or quarterly, like if you had 100 observations, number 25 would be here, number 75 would be in quarter three. And it shows you how spread away from the median those quartiles are. And then your min and your max are represented by these whiskers, like a cat's whiskers. So you've got the box in the middle, and the whiskers demonstrate the spread of the data and how symmetrical it is. You'll see some where this median line in the middle of the box is skewed way over, which means your data is also skewed. Box and whisker. And the cool thing about these is that you can put them beside each other if you're looking at like before and after drug trial. um, the box and whisker will show you maybe say it's a blood pressure trial. It'll show you the blood pressure before and after, like average blood pressure and the variability, and then average blood pressure after the treatment, or before and after the placebo. You can start to see side by side the impact and the variability of that impact. And then you got your good old scatter plot. If you got two continuous variables, definitely want to throw in a scatter plot and see if they're related, how they're related. And here we've got, you always want to put the independent variable, the thing that is causing the change in Y. So you've got salary along the left-hand side, increasing from 0 to $250,000. And, your salary determines what kind of car you drive. Generally, more often than the car you drive generating your salary. I mean, if all it took to get a raise was buy an expensive car and drive into the parking lot and impress your boss, hey, that'd be cool. But generally speaking, the more money you make, the nicer the car you drive. And this line of best fit is that you can fit that with different models. You can fit that linearly, you can fit it exponentially, logarithmically, and you'll get a function that visually you can tell fits the data. And this, we can tell there's a fairly good linear correlation. So Pearson's R is the number you're looking for. So yeah, those are, there's basic chart types, and then we start to get into you can draw graphs in in Excel, Power BI. There's a filled map library out there with Python. So one of the things I saw on social media, and being a data guy, a data scientist, I saw my less informed friends complaining about in 2016 the claims that Hillary won the popular vote. She couldn't have, because this is a county level map showing Democratic votes in blue and Republican votes in red. And just look at all that red. So Donald Trump must have won the popular vote. He must have gotten more actual individual votes than Hillary, because there's so much more red. Just look at the map. Can't you tell? Get in line, sheeple. But as we all know, the blue areas here that vote Democratic are, generally speaking, the metropolitan areas, generally. So you can see there's a dot for left down towards Florida. There's a dot for Orlando. There's a dot for Tallahassee, the capital. There's a dot for Gainesville, which is where the largest state university is in Florida. There's a blue county, that's Hillsborough County, Tampa, Florida. And then virtually all of Miami-Dade and maybe Palm County there. And then you can see in it around Atlanta, around Washington, D.C., Philly, New York, out in L.A., San Francisco, the major, Austin, Texas, Dallas, Texas, the major metropolitan areas where all the people are, Chicago, um, people generate the popular vote. Um, but no kidding, in 2016, I saw, uh, let's call it uninformed friends of mine proposing that we should do the electoral college by county, and it should be how many counties you win, regardless of how populated that county is. So you've got counties in this country that are more populated than entire states. There are counties that are far more populated than Alaska or Wyoming, for example. So anyway, yeah, you can do graphs, just geographic charts in Microsoft pulls in algorithms from Bing, um, and they are very interesting to show you what's what around the country. And you'll see these all the time with COVID. You know, what states are showing an increase in COVID and which ones aren't, and that's all mappable with Excel and Power BI. And then you've got these are interesting. This is a camera on a computer watching your eye go to a website, and you can see in Western culture, the you read from left to right. So the upper left corner, which is where anybody that sees a page, automatically starts. It's got the most because it's darkest. That's where they went and how long their eye dwelled. Changes the heat map from green to yellow to red. Red meaning the most. So if you want, and where this is used is it proves to the web designer that you put the most important thing in the upper left corner. But also you see there's over the images, they tend people the eye looks at pictures first, and you'll see that in Facebook. Uh, Somebody will copy and paste that old meme about, oh, I know people don't look at a post without a picture. So if you read all this way, cut and paste on your page and then say hello. It's kind of lonely. And anyway, yeah, the human eye looks at pictures. Duh. And here's an interesting one I found on air routes. It just shows the size of the airport is a bubble. And then there's a line drawn to every other airport in the world where they have flights. And if you notice the the thing that you wouldn't have necessarily thought, uh, when you saw this data, if you saw a list of airports and um, and daily flight times and a list of two airports, that they're destination airports, you might not necessarily know. Oh, by the way, the color, it just shows it's just differentiating by time zone. Don't read too much into that as far as the data goes, but check out how there are uh, no geographic lines here, right? There's no map of the continents or countries on this. This is just dots and lines, but yet you can absolutely see the outline of Africa. You can kind of see the diamond shaped Indian Peninsula. South America is very distinct in its shape. North America is fairly distinct, and that's just from their airlines. One thing that helps that is a lot of people live on the coast. Um, and that you might have seen that in temperature change analysis. So much of a proportion, I think it's the majority, I want to say 60 or 70% live within 5 or 10 miles of the ocean. So that's where you happen to have a lot of airports. And anyway, this an interesting visualization. Now here's one that goes back, and you can watch. There's videos. This gets analyzed a lot. Tuft, Edward Tuft, uses this in a talk. What you've got here is the 1812, 1813 fatal march to Moscow by Napoleon. And it's both a map, a relatively accurate map that shows river crossings and whatnot. And it shows a proportionate size in Napoleon's grand army over time. It's accompanied with a line graph at the bottom. But what happened was, Napoleon's, kicking it all around Europe, taking on all comers, to include going down to Egypt and shooting the nose off the Sphinx. Right? Napoleon was a pretty notorious general, emperor. So sure enough, he decides, I'm going after Moscow, I'm going after the Russians. And he had 400,000 troops in the spring of 1812. And then he starts the march east towards Moscow, right? So from left to right, you can see about an inch from the left, you can see a line of troops head out. That was a conscription that ran out of their time, or a militia or whatever that he paid for. And they're like, we're done. See you. And they left. And then one of his generals took a small portion of the force and branched off, but they eventually they got caught up and eventually rejoined the retreating force about halfway down here at the bottom. But you can see this big pink line getting smaller and smaller and smaller through battles, but mainly starvation. And it gets smaller and smaller and smaller and smaller and smaller till the right. And they spell Moscow Moscou in French. But this is where they gave up in the winter. Can't take it anymore. And the black line shows retreat, shows westward movement. And you see the winter taking its toll, taking its toll, taking its toll. Now, where the two black lines join down here, that's where his alternate force retrograded and joined the main force, and it briefly increased the total size, but not for long. They did another river crossing and half of them died, and it goes down, 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 down. And then look at how small, I think it's 10,000 men, how small the Grand Army was when he got back to, I don't know, I'm not even sure what river that is, the Somme or something in Poland, probably. Anyway, this is just an interesting graphic that was developed a long time ago in 1869, I believe by Menard. But anyway, just an interesting specialty visualization. So there was a German psychiatrist, Gestalt, or psychological principle, Gestaltism, that emerged. Gestalt is German for form. So it's not a person; it's a concept. And the idea was that if you present information or present things a certain way, it makes it easier to see patterns as opposed to the individual components, which is what we're doing with data visualization, right? So here are, and you see different lists of Gestalt principles: proximity, similarity, connectedness, common region, common fate, continuity closure, and figure ground. So proximity, you can see here, we do a scatter plot, say, and you can see that there's kind of a group in the lower left-hand corner and then kind of a group in the upper right-hand corner. So we tend to assume that there's some sort of something in common with them, something similar. But similarity, we can even use different colors, different shapes, to prove that they are similar to the human mind. So now we change the color of those two groups to green and yellow, and we see that there is something, in fact, different. This would be a third variable. You've got an X and a Y, and then the green and the yellow would need to be some categorical variable, like perhaps it's I don't know, weight and height, or your continuous X and Y, and then you've got sex for your categorical variable inside there. So it's actually a kind of a multivariate analysis. And then here's another similarity. We assume on the right-hand pie that the two orange wedges are related and the two blue wedges on the left are related somehow. They are subcategories of the same thing. Whereas the pie chart on the left, you draw no such conclusion. They're so far apart in color that you don't see any similarity between the wedges. So it depends, when you choose your pie chart colors, that's something for you to keep in mind. Okay. Connectedness. The human mind always sees things that you draw a line between as connected, whether they're the same color or not. If these dots were all the same color, the ones that were connected would look as belonging to the same group. Now, common region is something you can often do in data visualization, in your charts, in your dashboards, is draw a line around stuff. And that makes the human mind leap to that, to say that these must be related because they share a common region. So this is the same part chart as before. So just drawing a black line around the group of orange wedges on the right guarantees your viewer will get the the point that they are related. Common fate is effective in animated motion. If you Google Hans Rosling, he does a talk on infant mortality over time. Hans Rosling. I'll try to remember to put that in the classroom. Continuity is where they're together and they form a trend or a path, or if there's no reason to put like products in alphabetical order, for example, here, or stores in your company, or whatever the case may be, the data kind of jumps around, and it's hard to do relative analysis, visual relative analysis on that left-hand bar. But if we sort them by sales of the product, then you start to see that we sell more of product D than a little bit less of product B, and it makes more sense because of the Gestalt principle of continuity. And closure is an interesting one. This is where the human brain looks at a drawing, a thing, a graphic, and sees something that's not really there, because you're filling in a void. Your brain autofills, auto completes the graphic. And uh, some examples here are: all it takes is a little void in the purple flower here of NBC, of the peacock logo. All it takes is that little tiny void for the beak, for the peacock's head and beak, and suddenly you have um, a peacock with tail feathers, as opposed to these six weird balloons. That's all it took, just a little tiny bit. But the human brain now fills in all of the void. IBM's historic logo, really just a series of white lines on a blue field. White lines in the foreground, blue automatically becomes the background in your mind, and the brain fills in the gaps of white to make those letters. And then yeah, figure ground, that's the next principle that we'll talk about, factors into this a lot. But look at this one fund logo. So they've got what looks like a numeral one, and then it looks like an F, but really all it is just two little quadrilaterals over there, right? But the human mind fills in the gaps and automatically creates closure without even thinking about it. So that's why it looks like a 1F, one fund. And then figure ground, according to Gestalt principles, uh, the human mind sees things um, in the foreground. Um, Generally, we see things in the foreground, and that goes back to the study of human perception from like a survival standpoint. The lion in the foreground is more important than the grass or the jungle in the background, so it jumps out at you. But a couple of classic indicators of this are like this vase. It's kind of complex, and it's in the foreground because of the plain white background, and it's got the more complex shape and shadowing. So the yellow vase, well, it looks like a vase, but when you just turn that into a monochromatic image where all you see is a very simple foreground and background, and black automatically comes to the fore, becomes the foreground um, for the human mind, and white becomes the background. Now you see that it looks like the silhouette of faces. So it's just all how you alter the color and whatnot to bring attention to what you want the human to perceive, really, I guess, or it's just to take into account what is the human going to perceive when they see my graphic, and is there anything I can do to shape that using some of this perceptual psychology. And then we have the good old, what do you perceive here? When I first see um, the picture on the right, I always see an old woman first with her looking to the left with her chin, and then you see the line of her nose, and the scarf flowing off to the right. But then if you notice, the um, the old woman's mouth becomes a choker style necklace on a young woman, and the old woman's nose becomes the jawline of a young woman, and the old woman's left eye becomes the ear of a young woman, and the little tiny wart on the old woman's nose becomes the nose of the young woman looking away from us, also to the left. That's an interesting old, but it's yeah, Gestalt principle of figure and ground and which one you see. And this one is very difficult because there's nothing distinct about it. There's kind of equal um, contributions of foreground and background. Okay, so I wanted to switch over to Power BI and just show you real quick what this looks like. Let's see. So Power BI is a desktop application that you download for free from Microsoft. And it looks a lot like Excel, only when you go to do your graphs, um, it doesn't um, bother you with grid lines by default like Excel does. So the basic workflow for Power BI is to go get some data. And over here, um, we have our data fields. I'll click to that view. So and this is called the Power Query Editor when you're actually transforming data here. I'll click transform data. And that brings up the Power Query Editor. And this view, this portion of the workflow is where you would bring in CSVs, or you would manage the connection to a real-time, stored procedures in a database or something that's pulling data into your visualization live. So yeah, it's not letting me in because I'm not logged in. But anyway, this Power Query Editor is where you transform, you rename your columns, you get rid of columns you don't need. You would add calculated fields and whatnot. So this is your T in an ETL process: extract, transform, and load. And it's kind of like a separate portion, a separate um, part of Power BI. So you get all of these sheets: age group, BU, date, employee, ethnicity, FP. You get all of these are all tables basically. And then you can have calculated fields in here that are part of your data, but that come in really handy when you go to use them later. You have to create them here, if calculated fields and whatnot. So yeah, this is the data view. And then once you get the data in and where you want it, Power BI will try to relate it based on the same field name. If it sees an identical field name in two sheets, it will assume that it's linked, but sometimes it gets it wrong. So you can drag and drop. And I mean, y'all are computer scientists. I'm sure you've seen this is an entity relationship diagram, basically, but it's live on the data. So when you do visualizations and you start to click on things, it sees how the data is related. Power BI will take action based on this data model view. So you always want to make sure that your data model is correct once you get your tables and columns good to go. And like I said, sometimes it works automatically and sometimes it requires human intervention. But then when you're done with that, you are ready to move to your report view, which is where you have tabs that can show different visualizations on the same page. And like I said, they're linked. You start clicking on things and you start to see the other charts change. See, I clicked on mail, and now we start to see the other graphs filtering to just males just females. I'll click it again. See them change from male, and now change back to male. There you go. So, yeah, the interactivity of and interconnectedness of visualizations in Power BI starts to get pretty dramatic. And you can put, I mean, each one of these is a separate chart, a separate visualization that you decide the size, you decide the title, the scale, all of that, and you put them on this canvas. Each tab is a blank canvas. Like here, I'll hit a plus, bam, blank. So you almost like let me delete that page. Don't need it. You decide. Here we'll do the male, female back again. Male, female, and generally you can filter each visualization if you wanted to see what's being filtered when you click. That's pretty handy, right? What filters are affecting this visual? You just hover over the filter. So yeah, Power BI. And you can download these from Microsoft. These are all widely available example projects. Each file in Power BI becomes a PBIX file, and there are many, many, many available out there on the internet for you to see what can be done. And lots of lessons out there. Microsoft Learn has lessons on Power BI again, and what little I know, I learned from LinkedIn Learning and Pluralsight. And here's another scoreboard. So that's and the author decides the size and nature of all these visualizations. And once you have a viz like this, you can publish them to the Power BI service, which is kind of like a database of these different visualizations within your organization. And then you can create a dashboard where you can pick and choose these visualizations and put them on a web-based presentation where they can't be edited or authored. They can be interacted with, but only someone with the Power BI desktop app really. Most of the authoring you want to do will be in the app, and consumption is meant for people using the Power BI service. Okay. And that was Power BI. Back to our week 5 discussion, which has nothing to do with data visualization. Instead, it's more about ethics and transparency. So for week 5 discussion, companies are still having a difficult time in protecting their data in digital format and defining what constitutes sensitive and non-confidential data. So sensitive and not sensitive data, and how to share the data, who gets to see it internal to the company. So what are the rights and roles and protections and groups within the company, so that, so that the guy sitting next to you can't see your salary. That only needs to be HR and, your supervisor and whatnot. And the way they share data with the public. Companies get lit up in the press all the time for using data about you without disclosing that fact or disclosing the data to yourself. Unlike in Europe, where they've got the GDPR, you have no right within the public sphere to ask for data about you. Within the federal government, there's an act of legislation called the Privacy Act that was responsible for getting your social security number off of a bunch of forms. They try not to use social security number on a form anymore that can just be thrown in the trash and now everybody knows your social security number. But it also allows you to make a request for all data about you that is being held by a federal agency, and you have to make that request to each individual agency. There are exemptions. If you're under investigation, they don't have to release it. There's a specific exemption for that. There's um, financial information they don't have to release, particularly if it affects like an ongoing contract negotiation. But generally speaking, yeah, you can request what data they got about you via the Privacy Act. So there's your um, so discuss technology's impact on data security and ethics in data analytics. There's the question. That's what it's telling you to do. Discuss technology's impact on data security and ethics in data analytics. All right. As always, any questions or concerns, please reach out via email.